Hello my dear students, welcome back. What a joy to see you back. How was the quiz? Good, I'm so proud of you. Here you are back victoriously, finishing your quiz and want to learn more. In this sub-lesson, we're going to talk about finding distance between 2 points in a Cartesian plane. Okay, so let's say for example, Mr. Mac, to give you 2 points, alright? Let's say point A, I have to give you 2, 3. And then point B, I'll give you 2, -2. And I want to find the distance, in other words, the length from point A to point B. So how do we do that? Well, Mr. Mac has already got a Cartesian plane on the board. So let's plot A and B on that, alright? Okay, let's do it. Okay, start with A. We know that this is going to be X and this is going to be Y. By now, you should able to know this is going to be X and this is Y. So Mr. Mac's not going to point out X and Y. We should know by now already, okay? So 2. So let's start with 2. 1, 2, and then up by 3. 1, 2, 3, right there. And that's point A. Now let's locate point B. B is 2, -2. That means right 2, down 2. So 1, 2, and down to 1, 2, right there. And that's point B. So we're looking at distance from A to B, right there. That's the distance we're looking for. Okay? So look at this. That's a vertical line. So to find the distance, look at that. How many units is that? 1, 2, 3, 4, 5. Only when it's a vertical and horizontal you can do that, alright? So that means so the distance to A to B is 5, okay? So AB equals to 5 units, alright? Let's do another point, okay? Let's do S and T. Let's say point S is, let's say I give you -4 and 3, and then T is, let's say -1 and 3. Okay, so we want to find the distance from S to T. So what do? We plot them, alright? Okay, let's plot S first. So let's find S is -4, which is the X. 1, 2, 3, 4. See that? -4 is right there because left by 4. And then up by 3. 1, 2, 3. That's going to be our S. And then T is -1. That means what? Exactly. -1 is right there. And then up by 3. 1, 2, 3. Right there. And that's going to be your T. Alright? So because this is X and this is Y. This is X and this is Y. And we know that X is -1. It means left to 1, up by 3. So now we're looking the distance from S to T. And this is the distance we're looking for. No, this is a horizontal line. So how many units is that? 1, 2, 3. So that means ST equals to 3 units. See that? Now look at this. When it's a vertical and horizontal, we can just count the units. Now you cannot do that if the line is like this. If the 2 point, if I ask you to find the distance between these 2 points, you cannot count because see that? Only when it's a vertical and horizontal we can count the 1 unit, 2 units, 3 units, 4 units, 5 units. When it's horizontal, 1 unit, 2 units, 3 units. See that? But we'll come back and talk about how to find the length when it's slanted, when it's not vertical or horizontal. Okay, we'll come to that. But let's understand when it's vertical and horizontal. Rather than counting like this, I want you to understand whenever you have a vertical, when it's vertical, the X are identical. You gotta have one, if A and B and S and T, the one axis has to be identical, either one, okay? If it's X is identical, then it's a vertical. If it's Y is identical, it's horizontal. So once you see this identical like this, like the 2 and 2, 3 and 3, when you're given to find a distance of 2 points, if you notice that, take the difference of the opposite one, and that's the length. Alright? Take the difference. Must be one side, either X side or the Y side has to be identical. That means like that, 2 and 2. That means I'm going to take the difference between 3 and negative 2. So what's the difference between 3 and negative 2? That means I'm taking 3 minus negative 2. Very important right there. Because you're taking the difference with negative 2. So 3 minus negative 2 is what? Negative makes it positive. So that makes it 3 plus 2, which is 5. See that? 5. Same thing with this one. Alright? The y are identical, so we will take the difference between this x and that x. Okay? So we found the AB is 5. See that? 5. Now let's find ST. Now remember, whenever you're looking the difference of 2 points, okay, ST. Now these two are identical and this is the one is different, alright? Because it's negative 4 and negative 1. Whenever you take a difference to find the distance, always take big number minus by the small number, okay? Big number minus by the small number. Okay, now negative 4 and negative 1, which one is bigger? Negative 1 or negative 4? Negative 1. See that? You owe less than negative 4. Negative 4 you owe more. That means negative is small number, alright? So that means you want to take negative 1 minus negative 4. Very important. Negative 1 minus, you're taking the difference between these two numbers. Okay, so negative becomes positive. So that means negative 1 plus 4. That means what? Same thing as 4 minus 1, which is what? 3. See that? 3. So it's very important, okay? Right, let's do another couple more points, okay? The distance of a couple more points. Let's say Mr. Mac to give you, okay, this time, let's say M. I'll give you, let's say, negative 2, 2, and then N is negative 2, let's say negative 1. And I want to find the distance of from M to N. Now look, X is identical. Okay, what does it tell you? It's going to be it's going to be a vertical line. All right, it's going to be a vertical line. So let's do that. Let's put that in the graph. All right, first let's locate M. X is negative 2 right there, and then M for y coordinate is 2. I mean up by 2 right there. This is M. For N it's negative 2 and then down by 1 right there. Okay, so that means I'm finding the distance from M to N right there. I'm finding the distance M to N, and it's a vertical line. If it's a vertical, I can count 1, 2, 3. But we don't want to use this approach. But I want to show you in Cartesian plane that when you have a vertical line like this, you can count it. That means I can take the difference for y. These two, the y1 and y2. Alright, so we're going to take the difference. So the distance MN equals 2. Let's say this is y1, y2. Always take the big minus by the small. So in this case, 2 is big. Okay, I'm going to start with 2 minus negative 1. Now you're taking the difference of this two coordinate. Alright, so these two coordinates. So you got to maintain the negative. Just because you're subtracting doesn't mean you got to skip the negative. No, you have to have 2 minus negative 1. You're taking the difference between these two coordinates. Alright, so the negative 1 was part of it. Okay, so you got to put that. So now look, 2 negative positive 1. 2 plus 1 is 3. So the distance from M to N is 3. See, 1, 2, 3. But you got to pay attention. Has to be what? The one side has to be identical, either X or Y. Alright? Then only you can do that. Okay, let's do another point. Okay, let's say this time Mr. Mac to give you U. So let's say if I give you U, let's say negative 4, negative 1, and then V is negative, actually let's say positive, let's say 3, negative 1. Alright? Look at this. The y this time is identical. The y is identical. That means it's going to be a horizontal line. Okay, let's plot that. Let's plot u and v into the Cartesian plane. Okay, so negative 4, so that's the x. So we're going to go left by 4, down by 1, negative 1. See that? Down by 1. So we're going to go 4. 1, 2, 3, 4. See, negative 4. And then negative 1 means down by 1 right there. See that? negative 1 right there. So it's going to be right here, it's going to be your u. And v is going to be 3, right by 3, okay, right, 1, 2, 3, see that, right there, 3. And then negative 1 means down by 1 right there. And that's going to be your v. So we want to find the distance from this point to that point. It's going to be a straight line right there. It's a horizontal line. Alright, now we can count 1, 2, 3, 4, 5, 6, 7. See that? So it comes to 7, but we don't want to maintain this, but I want to prove it to you by taking the difference between these two numbers will give me 7. Alright, so we take the big number, so let's say this is x1, x2, so we can take the difference, always take the big number, so we're going 3 minus negative 4. So uv equals to 3 minus negative 4. Minus minus or negative negative becomes positive. 3 plus 4 is 7. See that? And that's the distance from there to there. 1, 2, 3, 4, 5, 6, 7. Right there. Now this only applies if the line is vertical or horizontal. Okay? That means when the line is vertical, when the x are identical, the two coordinates, 2 points of that line, of the distance that we are looking for, the x has to be identical to be vertical. If it's horizontal, the y has to be identical, the coordinate y, alright, has to be identical, okay? Right there. This is going to be for vertical and this is going to be for horizontal, alright? See that? What happened? They're not same. That's where this kind of line will happen. When this kind of line happens, then we're going to use a different method of finding the distance. Alright, so let's do that. Let Mr. Mac erase the board and then we'll talk about it, and I'll be back within a few seconds. Okay, so let's find the distance over 2 points. Okay, let's say Mr. Mac give you A, it's 3, 2, and B, it's negative 1, negative 1. Okay, now look at this. The x points, they're not identical. What about y points? Also not identical. Alright, now previous we learned if they're identical, if one of them, we use the difference to find the distance. When they're not identical, that's how we're going to learn a different way of finding the distance. Okay, so it's very important. Okay, when they're identical, or let's say if x side is identical, we take the difference of this. If y side identical, we take the difference of the x side. Alright, so now what happens when the x side is identical? So what kind of line was that? Was that vertical or horizontal? If x side are identical, it's going to be horizontal. If y side are identical, it's going to be vertical. But in this case, neither of them are identical. It's going to be a slanted. Okay, going to be okay. It has a diagonal to it. So let's plot that. Let's plot that into the Cartesian plane. First, let's look at this. Is it been scaled? No, we're going to put scale them. Okay, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, it's very important. So this way you know where to put the points. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 1, negative 2, negative 3, negative 4, negative 5. Alright, let's look at point A, which is going to be 3, 2. So this is our reference point, the origin, 0, 0. So 3, that means right 3 up 2. So right 3 up 2. There you go, point A. That's our A point. Alright? And then for B, it's negative 1, negative 1. X is negative 1, Y is negative 1. That means left 1, down 1. Okay? So we're going to left 1, down 1. See that? Negative 1, negative 1. See that? Negative 1, negative 1. So that's going to be your B. So that's going to be B. So now we want to find the distance from A to B. There's no way for us to find the distance. Look at that. Like earlier when it's a vertical or horizontal, yes, we can count the unit. Am I right? This one, you cannot. Look at that. See that? How they are kind of broken, alright? So you cannot do that. So what do you have to do? Now look at that. If I to put a straight line down this way and down that way. See this intercepting right there. So that means if I to color this one right there, it form a triangle. Look at that. What kind of triangle is that? A right angle triangle. Can I find what's the distance of this? Can I find the distance of that? What is this? 1, 2, 3. Okay, that's 3 units. What about this one? 1, 2, 3, 4. See that? What that reminds you from our previous lesson? Pythagoras theorem. See that? 4 and 3. That means I can find this. This is what? The hypotenuse. See the right angle? The hypotenuse. So what the Pythagoras theorem says? A squared plus B squared equals to C squared. So that means I can find this because this is C, the hypotenuse. And I can label one of them to be A. Let's say this is A and this is B. So now I can just substitute and find what's the length of AB. So now let's do that. So A is, let's say 3. Okay, we're going to put 3 squared. And B is this one, 4 squared. And we're going to find C, okay, eventually, alright? So C squared. 3 squared, that means 3 times 3, which is 9. 4 squared, 4 times 4, which is 16. 9 plus 16, 25, okay? But we're looking for C. That means I have to take square root of the C squared in order to find the C, am I right? If I square root this, I have to square root this side. So what will happen? C equals to 5. So the length of AB is 5. Pretty easy, isn't it? Very straightforward, okay? Let Mr. Mac erase the board this side, alright? Let me erase this, okay? I'll be back with you in a few seconds. Alright, my dear students, let's find another 2 points distance, okay? So this time, let's say Mr. Mac to give you R -3, 3 and S 1, -2. So we want to find the distance of RS. Okay, now look at this. First you want to check, are they look identical? No, they're not. That means neither of the axes like X or Y are not identical. So that means we're going to use the Pythagoras theorem way of solving it. Okay, so let's plot them. So it's a good idea. Always look and see, are they identical? When I give you 2 points and ask you to find distance, so your first step ought to be, see X, are they identical? No. Is Y? No, they're not identical. That means you have to use the Pythagoras theorem method to find the distance. So let's plot R. R is -3, 3. Now always look for the reference point, which is the origin. -3, that means left by 3, 1, 2, 3, and up by 3, because Y is +3, okay? 1, 2, 3, right there, that's the point right there, okay? That's going to be your R. And S is going to be 1, which is right by 1, okay? So right by 1 and down by 2. So 1, 2 is right there, okay? So let me, Mr. Meg, erase that, so now we can put the point right there. And that's going to be the S. So we want to find the distance from R to S, right there. That's the distance we want to find. So what do? We put a straight line down this way and straight line down that up, vertical line and a horizontal line. See this intercepting right there? That's going to be the point where we want to find the distance from R to that point and then from S to that point, because that makes a right angle right there. The point where this line goes straight and where it's intercept, that's going to be the point that was going to make a right angle, and that makes a right angle triangle. When it makes a right angle triangle, that fulfills Pythagoras theorem. Okay, so that means I can find the length of this and find the length of that and use the formula A squared plus B squared equals to C squared. Alright, so let's find the length of this. Let's say we put this is A and this is B, and you know this is what? Hypotenuse. Always the one you're looking for distance. Alright, always will be the hypotenuse. That's automatically becomes C. So this is C. Alright, so that's what we're looking for. So A is, what's the length of A from this point to this point? 1, 2, 3, 4, 5. So that's going to be 5. Alright, so it's going to be 5 squared, and B from this point to that point, 1, 2, 3, 4. So it'll be 4 squared equals to C squared. 5 times 5 is 25. 4 times 4 is 16. And then we're going to add them. Okay, so line it up. 25 plus 16. 5 plus 6 is 11. Carry 1. And then 1 plus 2 is 3 plus 1 is 4. So 41. Okay, so that gives me 41 equals to c squared. But I'm looking for c, because that's the length of c, which will be the rs. Alright, that means I have to take the square root of c squared in order to find the c. That means I have to square root of 41 also. So that gives me c square root of 41. Now square root of 41, it's a number that you cannot square root by our regular calculation. See that? So square root of 41 is not in our timetable, because we know 1, we can square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, 49 is 7, 64 is, see that? 41 is not there. So we got to use a calculator. Alright, here it is. Okay, let's look at this video. How to use calculator to find square root of 41. Alright, my dear student, we know that when you take a square root, a number that's in our timetable range, we know how to find them. Like for example, square root of 64, which is what? 8, because we know that 8 times 8 is 64. That means square root of 64 is 8. Square root of 49, which is 7 times 7, which is 49. That means square root of 49 is 7. But what happens if the number that we're going to square root, it's not a whole number, the two whole number that multiply? Like for example, let's say square root of 41 that we are looking for right now. Square root of 41, it's not in our timetable range. For example, we know that square root of 36 is 6, square root of 49 is 7. So 41 is fall between 36 and 49. So we're going to get a decimal number when we take a square root of 41. That's where calculator comes in. Alright, so make sure only certain problems you want to use calculator, but majority of time I want you to use your own method of calculating. Alright, so I don't want you to use calculator. In this case, you need to want to know what square of 41, you need to use a calculator. This is a basic calculator. If you have a scientific calculator, the function might be same, but the order of entry could be different. Alright, but with the basic calculator, if I want to find the square root of 41, I press 4, 1 and I press square root. See that? So that gave me 6.4031. So we're going to round it up to 6.4. Alright? Okay, so that's our answer. So square root of 41 is 6.4. See that? So what does it tell you? Square root of 41 is 6.4. 6.4. So C equals to 6.4. That means what? RS is 6.4. Pretty easy, isn't it? Alright, let's do one more. Alright, so let Mr. Mac erase the board here and we'll do one more. How to find the length, the distance, and especially when number is not square rootable, where we have to use a calculator. Okay, I'll be back within a few seconds. Alright, my dear student, let's find the distance of 2 points, okay, M and N. Let's say Mr. Mac to give you M, it's 3, -2, and then N is -3, -5. Alright, so what's our first step ought to be? In order to find the distance of 2 points, M and N, we first want to see if they are identical. If the points are identical on the either X or Y. Alright, let's look at X side. 3 and -3. Does that makes it identical? No, because this is -3 and this is +3. There's no way they're identical. Alright, and -2 and -5, that's kind of given. It's for sure it's not identical. Alright, be careful. 3 and -3, they're not identical. So that means this is not going to be a vertical or horizontal line. So it's going to be a slanted. Alright, it's going to be a diagonal. That means we have to plot it on a Cartesian plane. Alright, let's do that. So let's plot M first. So M is 3, -2. That means look for the center point or the origin. The origin is 0, 0. Okay, so that means 3 to the right, 2 to the down. Alright, so 3 to the right, 1, 2, 3, and 2 down, 1, 2, right there. That's the point M. M is right there. Alright, the N is going to be 3 to the left, 5 to the down. Alright, 3 to the left. From the origin, you go 3 to the left because it's negative. Negative, you go to the left. 1, 2, 3, see negative 3. See that? And then down by how many times? 5. 1, 2, 3, 4, 5. Right there. See that? Negative 5. So that's the point right there. So we want to find the distance from this point to that point. Alright? But look, it's slanted. Alright? So that means we're going to create a triangle for that line. So you go straight down like this, you go straight like that, vertical, vertical and horizontal. Where it's intercepting, that's where you draw the triangle. Where the vertical line and horizontal line intercepts right there. That's where you create the triangle. See that? Now I'm creating a triangle. So that makes it a what? A right angle triangle. So that fulfills the requirement that you needed in order to apply Pythagoras theorem, alright, which is what? A squared plus B squared equals to C squared. And C is the one we're looking for, because whenever you're finding the distance of M and N, that is the hypotenuse and that is the C. And we can pick either this one A and this one B. So we're going to find the distance from this point to this point, which is what? 1, 2, 3. So we know that's 3. And what about from this point to that point? 1, 2, 3, 4, 5, 6. Okay, so that's 6 and that's 3. So let's substitute A with 3. So 3 squared plus 6 squared equals to C squared. 3 squared means 3 times 3, which is 9. 6 squared means 6 times 6, which is 36. And we're looking for C eventually, but we write down as a C squared. So 9 plus 36, let's line it up. So 36 plus 9, 6 plus 9 is 15, 5 carry 1 plus 3 is 4. So that's 45. But again, we are looking for C, but you got C squared. In order to find C out of the C squared, what do I have to do? I have to square root. If I square root this side, I have to square root this side. I have to do it evenly. That means C equals to square root of 45. Again, square root of 45 is not in our timetable range, because it's not in our timetable such a way that we can find the square root, because we need two identical numbers that multiply will give me 45. Because we know that 6 times 6 is 36, 7 times 7 is 49. So look like it's fall between 6 and 7. So it's going to be a decimal, because 6 times 6 is what? 36. 7 times 7 is 49. But this is 45. So we can use a calculator to find the square root of 45. Alright? So let's do that. Here it is. Watch how Mr. Mac used a calculator to find the square root of 45. Alright, my dear students, we're going to learn how to use a calculator. Now there are certain numbers, when you find a square root, you have to use calculator. For example, if I ask you what is the square root of 45, there's no way to know what the square root of 45. If it's a square root of 64, it's our timetable range, which is 8 times 8 is 64. So that means square root of 64 is 8. But 45, there is no round number, whole number, which you multiply. Two whole numbers that multiply will give you 45. See that? So there's no way for us to find the square root of 45. So that means you have to use a calculator. Now this is a basic calculator. If you have a scientific calculator, the function might work differently, but all of them has this square root button, alright? But the sequence of pressing might be different, alright? With a basic calculator, something like this, the sequence would be, if I want to find the square root of 45, I press 4, 5, and then I press square root. Square root of 45 is 6.7082. But we want to round it up. We want to round up to the first tenth. Okay, the 10th decimal. So it will be 6.7 square root of 45. Now, of course, if you want to take a square root of 64, for example, okay, so let's say 64 square root. What does it give you? A round number, 8. But we know that 8 times 8 is 64. So we don't have to use a calculator. The only time that you want to use a calculator is if the number is not square rootable using our timetable range. Okay? But remember, when you square root the two number, the round number has to be identical. See that? So that's why we couldn't use the timetable. Alright? Like say for example, the square root of 45, what did we get? 6.7. it's not a round number, it's not a whole number, it's a decimal number. That's why we need a calculator. Okay, now let's take another number. Let's take square root of 75. So how do we find the square root of 75? Now first, is it in a timetable range? Is that two whole number when multiply will give me 75? No, because if you notice, let's see, 8 times 8 is 64, and what's the next? 9 times 9. 9 times 9 is 81. So 75 is fall in between 64 and 81. So that means it's going to be between 8 and 9. Alright, so let's find out what is square root of 75. So how do we use this calculator to find a square root of 75? We press 7, 5, and then press the square root. Okay, and that gave me 8.6603. So what we want to do is we can round it up to the 10th. Okay, 10th place. Okay, alright, that means it will be 8.7. So in other words, you don't have to write 8.6603, just round it up to the 10th. So it'll be 8.7. Alright, okay, let's do another one. Let's take, this time we want to square root 98. Now again, a square root 98 is a two identical whole number, but identical whole number that can give you 98? No, because we know that 9 times 9 is 81, 10 times 10 is 100. So 98 falls between 81 and 100. So it's going to be a decimal number. Okay, let's find what square root of 98 is. Okay, 98 square root. Alright, and that gave us 9.8995. See, 9.8995. Again, we want to round it up to the first 10th place value. So it's going to be 9.9. So you can just write down, so square root of 98 is 9.9. See that? Pretty easy, isn't it? Straightforward how to use a basic simple calculator like this to find square root. Alright? Now again, if you have a scientific or something advanced level of calculator compared to this basic calculator, the sequence could be different. It may require you to press the square root first and then the number. Okay, so in other words, square root and then 45, square root and then 75, square root 98, like that. Alright, but with a basic calculator, you put the number first and then you press the square root. Alright, so you can play with it because each calculator comes with a manual. They do instruct you how to use them. Alright, my dear student, let's go back to the classroom and learn more. So now we know what the square root of 45 is. 6.7. Okay, so 6.7. C equals to 6.7. See, problem like that you have to use calculator. That's an exception. Certain thing you can use calculator, but majority of times the Mac do not encourage calculator because calculator is not meant for understanding to learn mathematics. Okay, I want you to learn on your own without calculator, but certain things, there are a few times Mr. Max say go ahead, use calculator. Okay, because there's no way for us to find the square root of 45 without a calculator. Okay, so which we found, C equals to 6.7. that means the distance from M to N is what? 6.7, because that's a C. See that? Pretty easy, isn't it? Straightforward. Alright? Okay, good. Well, guess what? That tells you what? Times for hands-on practice. Yes, it is time for hands-on practice. Before we do hands-on practice, we get to the, let's see what Pablo's doing. He's busy doing his hands-on practice. Alright, okay, worksheet. So we'll wait, we don't call him right now. Let Mr. Mike erase the board, get ready, and then we'll call him out. Okay, I'll be back with you in a few seconds. Alright, my dear students, are you ready for some hands-on practice? Alright, I know you are. Well, let's call Pablo, alright? Pablo, come on over, Pablo, come on over, bring over the worksheet. Our dear students are ready for some hands-on practice. Alright, dear students, Pablo's going to hand over the worksheet. Once you get the worksheet, be sure to pause the video and then invite Mr. Mackey once you're done. Alright, here it is, have fun. Good. Alright, my dear students, so you're ready? Okay, let's do problem 1. The problem 1 says find the distance between the following pairs of points below. Okay, so I got 4 problems. Okay, let's do 1A. Alright, 1A. So 1A, we're given 2 points, R, and the coordinates are 4, 2, and S is 7, 2. Alright, so we want to find the distance of that 2 points. In other words, RS, we want to find what the distance is. Okay, whenever we want to find the distance, what is the first step ought to be? We should compare the coordinates, the X coordinates and the Y coordinates, see if they are identical. If they are identical, we just take the difference, okay, of the one that's not identical. Okay, let's start with X coordinate. 4 and 7, they're not identical. How about the Y coordinates? 2 and 2, they're identical. Okay, that means we know it's going to be it's going to be a vertical line. Okay, when Y is identical, it's going to be a vertical line. So we're just going to take the difference of the X points, alright, the X coordinates. So we're going to take big number subtracted by a small number. So between 7 and 4, 7 is big, so I'm going to take 7 minus 4. Okay, that's going to give us a distance, RS, which is 7 minus 4 is 3. So RS is 3. That's it. Pretty easy, isn't it? Okay, so only applies when the coordinates of either X or Y are identical. Alright? Okay, let's do the next one. Okay, B. So B, a given point, the point is negative 3, 5, and T, and then U is negative 3, negative 2. Okay, so before we want to find the distance, we want to compare the coordinates. Let's start with the X. Is X coordinates identical? Negative 3, negative 3. Yes, that means we can take the difference of the Y coordinates to find the distance. Now, if the X coordinates are identical, what type of line is that going to be? Vertical or horizontal? Exactly, it's going to be a vertical line. Alright, so when you have an X coordinate identical, it's going to be vertical line. That means you're going to take the difference between the two Y coordinates. Alright, so we're going to take a big number subtracted by the small number. 5 and negative 2. Who's big? Of course 5, not negative 2. Alright, so we're going to take 5 minus the negative 2 because you're taking the difference between these two coordinates. Alright, negative and negative, it's going to be positive. So 5 plus 2, which is 7, and that's the TU. So we're finding the distance of TU. So TU equals to 7, and that's the distance. Alright, okay, let's do C. Now C points are given as V, negative 5 and 6, and W is negative 9 and 6. Alright, so let's compare the coordinate. First, let's start with X coordinates. Negative 5 and negative 9. They're different. Alright, how about 6 and 6 for Y coordinate? They're identical. Alright, now what kind of line is this going to be? A vertical or horizontal? Even the Y are identical. Exactly, it's going to be a horizontal line. Alright, so that means we can take the difference of the X coordinates. Alright, we take the big one subtracted by the small number. So between negative 5 and negative 9, which one is big? Negative 5. That's right, because you owe less, this one you owe more. Okay, that means the better you don't owe, you owe less is much better. That means it's a bigger. Alright, okay, good. So that means negative 5 minus negative 9. You're taking the difference of the two negative numbers, okay? So make sure you maintain the negatives. So VW, the distance of VW is negative 5 minus negative 9. Negative, negative, positive. So it becomes negative 5 plus 9. Now this is also means 9 minus 5. See, I can rearrange it. I can put the 9 first, negative 5 behind. Same thing. See that? So that means 9 minus 5 is 4. So the distance of VW is equals to 4. Okay, good. Let's do problem D. Now D, also you're given 2 points. Point X is negative 7, negative 2, and Y is negative 7 and 4. Same thing like we've been doing. What we're going to do first, we're going to compare the coordinate. Let's start with the X coordinate. Negative 7, negative 7. They're identical. That means what? We're going to take the difference of the y coordinate, -2 and 4. And again, when we want to take the difference of the y coordinates, what we have to, how the arrangement ought to be? Big number subtracted by the small number. Okay, so we can take 4 minus -2, because we know 4 is bigger than -2. All right, negative become positive, so 4 plus 2, because you're finding the distance of xy. All right, so xy equals to 4 plus 2 is 6. That's it. You got it? Good job. Proud of you. All right, good. Well, let's do problem number 2. Well, let Mr. Mac erase the board and then we'll do problem number 2. I'll be back in a few seconds. All right, my dear students, you ready for problem number 2? Let's do it. All right. Now, problem number 2 says find the distance between the 2 points below. Okay, without calculator. Okay, let's put down the problem 2 points. Problem 2 points are A, -2, -6, and B is 3, 6. Okay, so what's our first step? Compare the coordinates. Okay, the x coordinates -2 and 3, they're different, and B y coordinates -6 and 6. Are they same? No. -6 and 6 are two different numbers. All right, so they're not same. So when they're not same, either x or the y coordinates, what we do? Exactly, we're going to use the Cartesian plane. All right, so we're going to plot that, and then we're going to use the Pythagoras theorem as a way of finding the distance. All right, let's do that. Let's locate A first. Plot A. So -2, -6. Start with the 0 as our reference point. Okay, the origin, and then we're going to go to the left by 2. 1, 2. Okay, before that we got to scale them. It's not been scaled. All right, let's do that. First we put 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, and then this is going to be -1, -2, -3, -4. All right, then we're going to go down, -1, -2, -3, -4, -5, and -6. All right, so now let's plot the A point. All right, so -2, x is -2, that means what? Left by 2, that means 1, 2, see the -2, and then down by 6. -6 means down by 6. Okay, so 1, 2, 3, 4, 5, 6. See that? -6. See that? So the point A is going to be right there. So we're going to put A right there, and then let's find point B. B is 3, 6. X is 3. That means right 3, up 6. See that? Right 3. So 1, 2, 3. So that's 3, up 6. 1, 2, 3, 4, 5, 6. Right there. Well, that's a long line. I may need a straight edge, okay? I need a ruler. All right, let's do that. Let's put a straight line from A to B. All right, so it's very important that we also label those points so that way we know that's B. All right, Mr. Magdalene, put that right there, B. So now we want to find the distance from A to B. All right, but see that it's not a vertical or horizontal line, so we got to use the Pythagoras theorem. All right, so that means we want to find the horizontal and the vertical length first, which is A and B. So in order to find that, I'm going to put a straight line this way, horizontal, and then vertical. Where it crosses, that's where the triangle forms. Okay, let's make it darken it. All right, this is the horizontal side of the line of the triangle, and the vertical side of the triangle. That makes it what kind of a triangle? Right angle triangle. That's the only time that you can use Pythagoras theorem, if it's a right angle triangle, using the a squared plus b squared equals to c squared. All right, so the Pythagoras theorem is a squared plus b squared equals to c squared. That means we know this is what? Your c, always that's the hypotenuse. Okay, so we know that's the c we're looking for, and we want to label this as a and this as a b. So we can find the distance from B to this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that means A is 12, and I'm going to square that. Now we're going to find B. B is this one right there. 1, 2, 3, 4, 5. Okay, that means that's a 5 squared equals to c squared. Now 12 squared means 12 times 12. What's 12 times 12? Our timetable. 144. Very good. 144. And then 5 times 5. 5 squared is 5 times 5, which is 25. All right, and that's c squared. And we're looking for c squared. So we're going to combine this first. So 144 plus 24, line them up. 4 plus 5 is 9, 4 plus 2 is 6, and then bring 1. So 169 equals to c squared. And we want to know what c, which is square root of the c squared. Alright, if I square root c squared, I have to square root 169. So c equals to square root of 169 is 13 times 13. Alright, which is 13. Alright, because which is square root, this is 13 times 13 gives you 169, and we just need 1 out of that, which is 13. So c equals to 13. Right there. Pretty easy, isn't it? Okay, good. That's the distance from A to B. So AB equals to 13. And that should be your answer. You got it? Good job. I'm proud of you. Alright, let's do problem number 3. Okay? Find the distance between the 2 points below. Correct to 1 decimal place. So I want it, so that means should tell you what? It's going to be a decimal number. That means you're going to use a calculator. The math's not big into calculator, but sometimes you have to use a calculator. All right? Okay, let's do it. Okay, first let's put down the point. 3 is question problem number 3. M is -1, 2. N is 4, -4. Alright, we're going to compare the coordinates. Let's start with x coordinate, -1 and 4, different. 2 and -4, it's different. That means it's not going to be a vertical or horizontal line. So we're going to plot it into a Cartesian plane in order to find the distance. Alright, so let's do that. So because it's going to be a diagonal type of line. Alright, so let's plot the M point first. -1, 2. So reference point is the origin point. So we're going to go to the right or left when you have a -1. Left by how many? 1. See that? -1. And then 2 up by 2. 1, 2. And that's your M. So that's your M. Always label it so it'll be easier. Okay? N is what? 4. -4. That means 4 is x. It means right 4. Okay? So 1, 2, 3, 4. Right 4. And -4, down 4. 1, 2, 3, 4 right there. And that's your N. Alright? So we're going to find the distance of MN. So let's put a straight line connecting those 2 points. See that? They're kind of slanted. So we have to use Pythagoras theorem. Alright? So that means we need to know the vertical and the horizontal. That means I'm going to draw a straight line like this and a straight line like that, and we'll see it intercept right there. That's going to be my triangle right there. That's the triangle. And it does fulfill the Pythagoras theorem requirement, which is why, because it makes it 90 degrees. Okay? So, and this is your hypotenuse, which is C. So we can label this one as A and this one as a B. Okay? So that means A squared plus B squared equals to C squared. So we're looking for C, but we can find A and B because it's vertical and horizontal. Alright? So A, 1, 2, 3, 4, 5, 6. See that? 6. Okay, that's 8. So 6 squared. Remember that. Okay, and B from here to there. 1, 2, 3, 4, 5. That means 5 squared. Okay, so 6 squared is 6 times 6, which is what? 36. 5 squared is 5 times 5, which is 25. So let's add them. So let's line it up. So 36 plus 25. 6 plus 5 is 11. 1, carry 1. 1 plus 3 is 4. 4 plus 2 is 6. 61. And we're looking for C. That means what? I have to take the square root of that in order to find C. That means I have to also square root 61. Okay, so we're going to find the square root of 61. Now square root of 61 is not in our timetable. Alright, because we know that 61 falls between, that square root will be what? 49 and 64, because we know that 49 is 7 times 7. 64 is 8 times 8. See that? So there's no round number in between, a whole number in between 7 and 8, because it's going to be a decimal number. See that? So that means it's going to be a decimal number, square root of 61. That means also what? It means we're going to use a calculator. Mr. Max not big fond of calculator, but sometimes you have to use a calculator. Alright? Okay, let's grab the calculator. I know you already know how to use a calculator, okay? So I'm just going to show you the basic calculator. So to find square root of 61, so what we're going to do is, we're going to press 6, 1, and then we're going to press 6 square root. All right, so give you 7.81024996. That's why I told you in a question, one decimal. All right, one decimal. That means we're only going to keep 7.8. We're going to round it up to 7.8. So that means square root of 61 is 7.8, which is equal to C. That also means what? The distance from M to N. So M to N equals to 7.8. Right there. Pretty easy, isn't it? All right, good. Well, that tells you what? End of the hands-on practice. Okay, good. That means also time for quiz. There you go, Pablo. Our dear Pablo already walking by, warning us. It's time for quiz, time for quiz. Thank you, Pablo. And thank you for daring our student. So make sure, my dear students, take the challenge from Pablo and go get him. Go do your quiz, all right? And then come back and see Mr. Mac on the next sub lesson, because I'll be here waiting for you. All right, my dear student, have fun. Bye-bye.